All right, let's talk C# on AWS Lambda. We're going to cover the entire developer journey, right from that first line of code all the way to watching it run live in production.
So you're a .NET dev, right? You love C#, you know its power, but you're looking at this whole serverless thing. And the big question pops up, how do you actually run your C# code when there are no servers to manage?
The answer? It's AWS Lambda. Plain and simple. It just runs your code when stuff happens, and you don't have to worry about the infrastructure at all.
Okay, so here's the plan. We're going to walk through this whole journey step by step. First, getting your environment set up. Then we'll write our first function. After that, we'll figure out how to deploy it, and then the fun part, making it fast. We'll also cover some super important best practices, and finally, figure out how to see what's really going on inside your function once it's out in the wild.
All right, first things first, we've got to get our dev environment ready to go. And honestly, the good news here is that AWS has made this super easy for us .NET folks.
So before we even think about writing code, there are just a couple of quick one-time things to install. You'll need the .NET 8 SDK, obviously, and then we'll grab the AWS Lambda templates and the command line tools. That's it.
And these are the two magic commands you'll need. The first one, .NET new install, hooks you up with a bunch of project templates. It's a massive head start. The second one gives you the .NET Lambda command, which is basically your Swiss Army knife for everything deployment related, all from your terminal.
Okay, environment's ready. Let's dive into the absolute heart of any Lambda function, the handler. This is it. This is the piece of code that Lambda actually runs every time your function gets called.
Think of the handler as the front door to your code. It's the one method that Lambda knows to call. It gets the event data, does whatever it needs to do, and then sends something back. Simple as that.
Now, in the .NET world, you've basically got two ways you can structure this. You can do a classic class library, a DLL, which is honestly the most common way and what we'll be looking at. Or you can go with a newer style, an executable assembly, like an exe file. The only real difference is how you point Lambda to that front door, that handler method.
So let's break down what a handler actually looks like. Up top, you've got your usual using statements. Then, you see this Lambda serializer attribute, super important. That's what turns the incoming JSON event into real C# objects for you automatically. Then you've got your class. And look here, notice how the S3 client is created outside the handler method? That's a huge performance tip. It means it gets reused across invocations. Finally, you have the handler method itself, handle request, which gets the event data and this iLambda context object, which is full of handy runtime info.
Okay, we've written some code. Awesome. Now, how do we get it from our machine up into the cloud? Well, that's our next stop, deployment.
Fundamentally, you have two ways to package your code up. You can go the simple route. Just zip up your compiled code and all its dependencies. It's direct. It's easy. Or you can package everything into a Docker container image. This gives you way more control and consistency, especially for bigger apps. It's really just a choice between simplicity and control.
Now, to push that zip file up, you've got some great tools. If you're just deploying one simple function, that .NET CLI tool we installed is perfect. Just .NET Lambda deploy. But as your project gets bigger and you start needing things like an API gateway or a database, you'll want to reach for an infrastructure as code tool. That could be AWS SAM, where you define everything in YAML, or the AWS CDK, which lets you define your entire cloud stack using C#. How cool is that?
All right, our function's live, it's in the cloud, it's running. Now we get to the really fun part, making it faster. Because in serverless, performance is king, and that's especially true when we talk about cold starts, that little delay on the very first invocation.
You know, one of the biggest performance wins you can get is all about how you handle JSON. The default way uses reflection. It works, but it's kind of slow because it has to figure everything out at runtime. But the modern way? It's called source-generated serialization. This does all the heavy lifting when you compile your code. The result? It's way faster, uses less memory, and it makes a huge dent in those cold starts.
But what if you need to go even faster? Like, what if you need the absolute best cold start time possible? What if we could just get rid of the just-in-time compiler, that thing that runs the first time and slows everything down?
Well, you can. That's exactly what native ahead of time, or AOT, compilation is for. With native AOT, your C# code gets compiled down to a native binary before you even deploy it. So when that cold start happens, there's no JIT compiler to run. It just goes. We're talking about taking startup times from maybe a second or more down to just a couple hundred milliseconds. It's a game changer.
Now, there are a few things you need to use native AOT. You'll need Docker running. the .NET 8 SDK, and you absolutely have to use that source-generated serialization we just talked about. The code also needs to be compiled in an environment that looks just like the Lambda runtime. But don't sweat that last part. The AWS tools are smart, and they handle all of that for you using Docker behind the scenes.
Okay, let's switch gears and talk about some essential best practices. Think of these as the pro tips for writing really solid Lambda functions.
Okay, top 5. Let's go. 1. Keep your business logic separate from your Lambda handler. Makes testing a breeze. 2. Keep your deployment package small. Don't include the whole AWS SDK if you only need S3. 3. We said it before, but initialize your SDK clients and database connections outside the handler. It's all about reuse. 4. Use environment variables for config. Never ever hardcode secrets or settings. And 5. Write idempotent code. That's a fancy way of saying your function should be able to get the same message twice and not mess things up.
And last but definitely not least, logging and tracing. Seriously, you can't fix what you can't see. In a serverless world, this stuff isn't optional. It's absolutely critical for figuring out what went wrong.
The easiest way to get started is built right in. That IL Lambda object we saw earlier, it has a logger on it. If you use that, Lambda will automatically create structured JSON logs in CloudWatch for you. And trust me, searching through JSON is way better than trying to find something in a wall of plain text.
And when you're ready to get serious about observability, you'll want to check out Power Tools for AWS Lambda. It's an awesome open-source library from AWS that makes adding structured logging, custom metrics, and tracing, well, it makes it incredibly easy. It handles all the boilerplate for you.
So there you have it. We've gone from zero to a fully deployed, optimized, and observable function. You've got the whole roadmap now for building amazing serverless apps with C# on AWS. So the only real question left is, what cool thing are you going to build next?